So this is the second part of 1.6. This is exactly where we left off. If you didn't catch the end of the video before, if you need to pause and watch and get that. So again, I'm going to emphasize how to use Desmos. Again, Desmos.com instead of a graphing calculator. But I'm going to show you how to use the tables again with this. So at the end of exercise 3, I gave you this clue that they're called zeros when the number you plug in for x that number is called a zero if the answer you get is 0. So if you get 0. So what I'm going to do is just type this into Desmos. So and clear out my last two equations. And you don't have to write x or y equals, I guess. You can just write x. Now if you notice, if I hit this key now, I'll make it x cubed. I'm going to hide this now. Plus 2x squared minus again, you can just hit this key for squared minus 16x minus 32. So every time that this crosses the x-axis, this curve I guess I should say, it's called a zero at x equals -4 because when you plug in -4 for x, you'll get a 0. It's a huge lifesaver. Now, Desmos is really good because you can just click on the screen and see what that value is. A graphing calculator, you have to hit a bunch of keys in order to get these values. Please don't forget, I'll move my screen. Over here is how you can zoom in or out. Now, which one of these three answers is the one that I actually want? Well, if you go to the directions, it says that we want the answer that is bigger than 0 but smaller than 10. So that's what this means. 0 is less than or equal to x is less than or equal to 10. So we want a number that's bigger than 0 but smaller than 10. And so when I go to that, well, -4 is to the left of 0, so that's smaller. We don't want that. -2 is to the left of 0, so we do not want that. And then 1, 2, 3, 4 is bigger than 0 but smaller than 10. That's the answer you want. So the answer that we want is x equals 4. Now, let's actually follow this table command that the question's asking for. Well, we can still do that in Desmos. And I actually showed that to you earlier. Is if I go and click on this screen, hit this wheel, I can click this table, and we can actually ignore this first value because it's to the left of 0. We don't care until we get to 0. And if I hit enter, that's the key I'm pressing. I didn't want to do that. I guess it won't let me undo it. At the end, I guess, is where you have to do it. If you hit enter, I guess it's not letting me do it. You could just type in values, and you can stop once you get the 0 that we're looking for. So of these 10 answers, the one that I care about is when x equals 4. All right. I've done this before where I can just hit enter several times, but for whatever reason, it's not letting me do that right now. So I just confirmed that that answer is x equals 4. So as we look at example 5, we can actually simplify this problem quite a bit. So let's do that first for part A. So you'd have to distribute these x's so that x times x is x squared, x times 8 is 8x, and then distribute the 5. So that's 5x, and 5 times 8 is 40. You can trust me or feel free to use a calculator. I'm going to leave this minus alone right in between. And what you'll notice is I'm putting things in parentheses because this is going to be a big deal. if I don't use parentheses, I'll get the wrong answer. So x times x is x squared. X times negative 2 is negative 2x. And distribute the 3, so it's plus 3x, and 3 times negative 2 is negative 6. So now I can combine like terms. We get x squared, combining the x's together, that's 13x. Can't do anything with the 40 just yet. Again, I'm going to put in parentheses. Leave the minus alone, and I'm just going to combine the right side. By the way, if I'm going too fast, please pause the video and rewatch. Now, how did I get plus 1x? Well, negative 2x plus 3x is 1x. So now I need to make sure I distribute this minus to every term. We have the distributive property again. So we still have x squared, but then I hope you're okay that I'm going to rewrite minus x squared next to it. Because remember, the commutative property, we can move things around. And then plus 13x. I'm trying to color code to help you as well. This becomes minus 1x. And then we have this plus 40. And when you distribute the negative to minus 6, it becomes plus 6. So as we look at all of this, the x squareds actually cancel each other out. 13x minus 1x is 12x, and 40 plus 6 is 46. So what I'm saying is, this original problem that we had at the top, so let me just put a giant arrow to right here, is equal to 12x plus 46. And so what I'm going to do is use Desmos to prove that. So all you have to do is pull up Desmos and clear out of all of this other stuff because that was an earlier problem, and just type in the fancy problem that they start with, x plus 5, x plus 8. And I hope you're realizing that this is more complicated than it needs to be. Like writing out, 4 different things. X plus 3, x minus 2. Just double checking I wrote it correctly. And then I'm going to create a second equation. That is that 12x plus 46 from right here. So now I could look at the graph. Like let me move my thing over. I could zoom out and you could see that they line up perfectly with each other. How do I know they line up perfectly? Well, if I click at this green is falling directly on top of this blue. Now, how can you show it using tables? Is go to your wheel and make these into tables. Hit it again and make this one into a table. Now, what we were supposed to do is examine at values like 0, 1, and 2. Okay, now it's working for me. So when x is 0, it's 46. When x is 1, it's 58. When x is 2, it's 70. This is a lot faster than going through and finding each problem individually. So I believe it was 46, 58, 70. You might even notice a pattern going on here to save you some time. If you don't notice a pattern, go back and again do the same thing. 82's match up, 94's match up, 106. So what are we doing by doing this? Well, if all of these y values are equal, then we can say that we did the problem correctly and that the two expressions are equivalent. So I think you are ready to work on the homework. Feel free to use Desmos. If you don't like Desmos and you have access to a graphing calculator, you can use that as well. And the PDF that I'm sharing in Google Classroom should be available for you to work on.